Hello, I'm Graham Roberts, and this is the last of my database series of tutorials. This one is about normalization, and we're sticking with the model that we've used before, but we're going back to the drawing board. Here we have a sales entity, and what do we know about sales? Well, we sell products. So we have a nice little sale, and we sell products 1, 2, and 3 on a certain date, and that gives us a total sales for that date, whatever that may be. So that's good. We can store 3 products. The problem is that product here is what we call a repeating group. Normalization, that's Normalisation, makes your data model flexible and reliable. It's a mathematical system. It does generate lots of overheads actually, because you get more tables, and we've seen a normalization process in the previous tutorials, but we didn't call it that. But that's what's actually happening. Here we're looking at it explicitly as a process, and this mathematical process has 3, 4, 5, 6 what are called normal forms. We only really need to worry about 3 in practice. The first form, that's form number 1, this states that there may be no repeating groups of columns in an entity. Now, product 1, 2 and 3 is repeating, so clearly this is not in first normal form. We could have created an entity sales with attributes for each of the products bought like this, but we didn't. But anyway, let's say we're starting again and we've done that. This is what it would look like, and it's not in first normal form because there's a repeating group, namely product. So what's wrong? Well, only 3 products can be sold. If you want to sell 4 products, how can you record it? You have to start a second sale, or adjust the data model by adding products attributes. That is, a product 4 attribute. This could go on and on and on. If you're selling thousands of products, wow, that's some entity. Both solutions are unwanted. We don't want these kind of solutions. In these cases, you should always create a new entity that you think can link to the old one via one-to-many relationships. That's what we did in a previous tutorial, but we didn't do it from this point of view. But we end up in the same place. So that's what we saw before. If you recall, we had sales as an entity in a relationship of one-to-many to invoice. This invoice could also be called sales details, if that makes it clearer. Now what we're saying is that the sales details will have the sales ID as a primary and foreign key from the sales in order to get this one-to-many, and in order to stop the repeating groups. That is, we would have sales, and for a particular sale there'd be a list of products with that sale ID here. So product 1, product 2, product 3, product 4, they'd all have the same sales number in the sales details table. This is the composite key if we take into account products as well, though we're just looking at these 2 tables being normalized. Now keep your eye on sales and sale details as we look at the second normal form. The second normal form states that all attributes of an entity should be fully dependent on the whole primary key. This means that each attribute of an entity can only be identified through the whole primary key. But what we had before was, inside sales, we had the quantity sold. That is, we knew how much was sold. Let's go back to this, the total sales. In fact, if we change that and call it instead quantity, when we make this link with the sales detail to put it into one-to-many form, we find by looking at this entity that the product goes into the other table, and so shall the quantity. And the reason is because the quantity is not dependent upon the sales ID, but rather upon the product ID. Remember that the primary key for sales is going to be the sales ID or sales number. So let's make this in first normal form. To make this in first normal form, we create this link, and product disappears, and instead what we get is sales ID. So now we've got the sales ID and the quantity. We obviously need the sales ID as a primary key, a primary foreign key, but we also must have the product ID, because otherwise we won't know what was purchased. So now the products have gone into the product ID, because now the product ID, which will change as a foreign key in here according to the product code that's been sold. So if you've sold 3 items, product code 1, product code 2, product code 3, then here you'd have 3 rows in sales details for one sale ID or sale number. Woo-wee! Now it's in first normal form. It's in first normal form because there's no repeating group. To get it to second normal form, we have to get rid of anything that is not totally dependent upon the primary key. Now, in actual fact, quantity, the number sold, is dependent not upon the date or the ID itself, but upon the number of products sold. So clearly, we need to say that the quantity will go into the sales detail. So we can actually just move it from there to over here to get it into second normal form. Okay, this is subtle. The reason for this is because what we're trying to do is get everything dependent on the keys. So yippee, second normal form. Let's take a moment to look at normalization. So the first form of normalization states that there may be no repeating groups of columns in an entity. And so it should be pretty easy to see that we yank all the repeated products in sale out so that they're on separate lines or separate records in another table, linked by the sales number. Now in the second form of normalization, all attributes of an entity should be fully dependent on the whole primary key. So we put into the sales details anything that wasn't, and we discovered that the quantity or total sold wasn't really anything to do with what was in the sales, but was really to do with what was sold, so it goes into the sales details. The third normal form states that all attributes need to be directly dependent on the primary key and not on other attributes. Now this one is more tricky to see. What we need to recognize is that the picture we had just now wasn't actually quite right. This is what we had. Because when we sell a product at a certain price, and you'd expect that to be in the invoice. You wouldn't expect that to be in the product table. It could be, but you wouldn't expect that. You'd expect it anyway in the invoice. And you'd also expect other things in the invoice which are not shown there. You'd expect, for example, the code of the order, the quantity, as we've said, and how much has been sold. Just think about what happens when you go to Tesco, say, or Sainsbury's, and you get a till receipt. What's down there are codes, the date, the quantity, and so on the receipt. But the part that's repeated, which is the receipt really, the list of items that you've purchased, that list of items will have information like how many units at what cost. Now, if you look back again at the rule, the third normal form of normalization states that all attributes need to be directly dependent on the primary key and not on other attributes. We find that the additional information that we kind of take for granted is in the wrong place. That is, it's actually in the products table, and we know that from earlier work, but what we're saying here is that if you had applied third normal form, we would have created the products table and put into it a link to the sales detail table. It shouldn't surprise you that what we actually just do is create the products table with a link to the sales detail table. Now, when we do that, we will have third normal form. But we had that already, and we can see it there, where we've got the sales linked to the products. Inside the products table, under the products key, we will now have unit price and so on listed. Then this is in third normal form. I haven't completed it fully here, but you should get the gist. Oh, by the way, I noticed that earlier I had second normal form with 1 NF. It should have been second normal form 2 NF. This is 3 NF, third normal form, but it hasn't been completed. It's incomplete. There are more than 3 forms of normalization. They go up, in fact, to 5 or 6, but they're not really usually certainly necessary in education. The normalized data model will end up with what we showed a few moments ago. So either way you can get to it. Even though you didn't know it, we were normalizing, but we were doing it, if you like, via common sense. And the mathematical patterning process kind of forces the same thing. The idea is standardization. The idea is that if everybody used the first, second and third normal forms, they'd all end up with non-redundant, efficient and effective relational databases. So it wouldn't matter which of your team you asked to do it, you'd end up with the same design. It isn't true, but it's a nice idea. And that's why normalization is so famous, because it's almost like you could see it as an idiot's guide to the end result, following a set of rules. I'll leave this slide for you to have a little look at. You can press pause. Okay, finally, as we're at the end of our tutorial, this is the longest of them, but hopefully I've left the best to the last. We've looked at attributes, cardinality, entities, foreign keys, a key, normalization, and a primary key. So let's look at what they are. Attributes are detailed data about an entity such as price, also known as a field in the actual database table. Cardinality is the relationship between two entities in figures. For example, a person can place multiple orders. We talk in an ERD of M to N and 1 to M and so on, 1 to 1 of course. Entities, abstract data that you save in a database. Example is customers, products and so on. Foreign key is always a referral to the primary key of another table. Foreign key columns can only contain values that exist in the primary key column that they refer to. A key is a key to point out records. The most well-known key is the primary key. Normalization is a flexible data model that needs to follow certain rules. Applying these rules is called normalizing. But you can get to the same result without even thinking about those rules. A primary key is one or more columns within a table, so you can have composite keys, that together form a unique combination of values by which each record can be pointed out separately. For example, customer numbers or serial number of a product, and so on. Well, I hope you've enjoyed this series of tutorials on databases, an introduction. What we have covered in the entire tutorial is really going to be clear from each of the individual tutorials. In tutorial 1 we looked at entities, 2 we looked at relationships, 3 we looked again at relationships but mutual dependency. In 4 we looked at the recursive and redundant relationships. In 5 we solved many-to-many relations, and in 6 we identified attributes. In 7 we looked at primary keys and foreign keys, and in 8 we looked at link keys, and in 9 we looked at data types, and of course in this one we looked at normalization. If you weren't clear about anything in these tutorials, I'm sorry, because I have to take the blame. And I hope if you look at them again and again they make some sense. Thank you for watching.